Good afternoon. Well, let's start the session 9 of pattern recognition. In this session, we have 4 papers. The first work is automatic classifier fusion for produce recognition. The authors are Faria, Santos, Rocha, and Torres. The presenter is Jefferson Santos.
Thank you. Good afternoon. My name is Jefferson dos Santos. I will present our work, which is automatic classifier fusion for product recognition. We are from Institute of Computing, University of Campinas. This is the outline of this presentation. I will give an introduction, explain our method, our proposed method, show the experiment protocol and the results, and discuss these results. So, fruit and vegetable recognition is a typical problem in supermarkets. One application is, a common application is to define the price of a product given its identification. The problem is we have many varieties of fruits and vegetables, and at the same time varieties interspecies. The motivation of this work is that existing product recognition approaches are not automatic. They usually use barcodes to assign the packages and booklets to find each product. The objective of this work is, based on this application, is to propose a framework for selection and fusion of classifiers for products automatic identification tasks. So this application, it needs to be real-time and at the same time active high recognition rates. But existing studies fail to get both requirements. Our solution is to exploit diversity measures to select specialist classifiers and combine these specialist classifiers using meta-learning. By avoiding redundant classifiers, it's possible to improve the time and the precision at the same time. This is the proposed classifier fusion framework. In this work, we use the idea we call basic classifiers, the couple descriptor plus learning technique. The framework is composed by 3 main steps. To build the final classifier, we have 3 main steps to perform. The first one is the training and the validation, the base classifiers training and validation. After, we have to select the base classifiers, which are most interesting based on diversity measures. And the last one is used in information in SVM meta-learning classification to obtain the final classifier. The available training data is divided into training set and validation set. The training set is used to train the base classifiers, and the validation set is used to compute the base classifier's opinion for each sample. So the output of this process is a matrix with the classifier opinion for each sample in the validation set. This information is used to compute diversity measures, and after this information to select the most interesting classifiers. Before to explain how we implement or how we, model the selection step, I will talk a little bit more about diversity measures. So it is useful to select subgroups of classifiers concerning. We can analyze the diversity between the pairs of classifiers, and but the question is how to obtain classifier. We can obtain classifier diversity using the same learning technique with different training sets, different techniques with the same training set, different techniques with different outcomes types, and using prediction as attributes in a meta-learning schema. In this approach, we use these ideas. We used 3 different diversity measures because it's interesting to use more than one, because this measure can give different opinions about the diversity between the couples of classifiers. To better understand the importance of using diversity, I will give an example here. Suppose this is a validation set, or a validation set. Each fruit is the label of the samples. So we have 5 samples, orange samples, and 5 grape samples. This is the results obtained using 3 different classifiers and the accuracy in the right. So the question is, which are the best candidates for a combination? If we just consider the accuracy, we can see that the first one and the second one are the best intercy to combine. But if we analyze the errors from each classifier, we can see that the classifier 1 and the classifier 3, they are almost complementary. So maybe this is interesting to combine. Using one of the diversity measures, it's possible to measure this diversity and use this information to select the classifiers between the three classifiers. So DFM is one of the diversity measures we have used, and it measures the double fault, where the classifiers are both with errors in each sample. So using this metric, we have 0, which is a good candidate to combine. So now I will explain the selection model. We have as input the validation metrics, which have, as I said, the opinion for of each basic classifiers for each sample in the validation set, and also the diversity measures. And we want as output a subgroup of classifiers, basic classifiers. This is the schema we have proposed. I will give more details. The validation matrix is the input. We use this information to compute the diversity measures, and for each diversity measure, we have a list with the couple of basic classifiers. Okay, and we consider this list, the ranked lists, the top positions in these lists. And the next step is to count the number of appearances of each classifier in these lists. So the classifiers which have the most appearance in the most appearances in these lists, in the histogram of counting, there are the selected classifiers. So after the selection process, selection step, we recompute the validation metrics, the opinion for each classifier. We reduce our space, and we use this information to train the SVM and to obtain the final classifier. But how can we use this final classifier to identify the class of a new image? The first step is to compute the using feature information. Use this feature information to compute the basic classifier's opinion, the selected basic classifier's opinion. After we can use the final classifier obtained in the last step to compute the final class of this image. So the experiment now. We have tested this approach in a real data set. It's a supermarket products data set which is available for to download. It's composed by almost 3,000 images of fruits and vegetables, divided into 15 categories. We have used 7 different image descriptors, 4 color descriptors, 2 texture descriptors, and 1 shape descriptor. As learning method based in the basic classifiers, we tested 3 different approaches. We have 5, but KNN we counted 3, testing with 1, 3, and 5 the key. And we have compared our method, our approach with previous results in other papers, and also some well-known techniques to combine classifiers. We compute to evaluate the methods, the accuracy in a 5-fold cross-validation protocol. So this is our results. In blue are our method. The first one is our method using all of the 39 classifiers. Why 39? Because, as I said, we consider basic classifier as the couple descriptor and basic and the learning methods. So we have 7 and 7, 49 different basic classifiers. Okay. So, but there are this is a lot of classifiers to process, and in a real world is not so good because we need to be fast. The application needs to be fast. So we tested with the best then classifiers, selected classifiers. Using 49, we achieve 98.8%. Using 10, the 10 best classifiers, we achieve 98%. This is the results using majority voting with all of the classifiers. But we can see that using only 10 classifiers, our method achieved the results almost similar, but similar as majority voting using all of them. This method, our method, obtained best results than baselines in other papers. And here is some results comparing to the learning methods, just using the best descriptors we have found in the experiments. We have performed some statistical significance tests to see if our method is really better than the majority voting. They are statistically different, even to the test performed to each class. We perform also some tests to measure efficiency. The extraction of feature vectors, it takes less than 1 second. The classification using the selected classifiers, around 1 second. The combination outcomes, less 1 second also. And the baselines reported around 5 seconds to perform the classification. So the conclusions. The proposed framework, it exploits diversity measures to select the basic classifiers for combination. It yields high accuracy rates in reduced time, is more effective than baselines, is able to not only select the classifiers, but we can detect the more appropriate descriptors for the target application. Using diversity measure, using the diversity measure, it allows the combination of non-correlated, high effective and low cost basic classifiers. And our approach is suitable for real-time produce recognition due to 2 reasons. All basic classifiers are low cost in terms of computational efforts, and only a reduced number of the effective classifiers are combined. As feature work, we intend to test more diversity measures. We intend also to apply other fusion techniques and develop a way to automatically select the number of classifiers based on the requirements of the application. And the last one is to investigate the use of this framework in other domains. We have already tested in remote sensing classification, and we achieved very good results. Thank you very much. I will. We thank the funding agencies. Thank you for your attention.
So questions? No questions?
Thank you for the presentation and the good results. I have a question. Maybe I did not catch the information, so please forgive me if you have said it already. I didn't understand what are the features that you are relying on for the classification. Is it
the final classification?
No. Are you considering the pixel values, the grayscale values, or are you extracting some shape?
No. To train the basic classifiers, we used the image descriptors, color histograms, for example, some shape information, texture information, and after, in the last step, we use the opinion from each basic classifier to compute the final classifier. Thank you.
Other questions? So I have a doubt. This method works with image with noise, like a plastic film, like I saw in an image.
In the fruits and the products, okay. Yes, for example, this. How do you know? Casual, yeah. Thank you. This is in the package, and there are a lot of how do you say? Real situations in this data set. It's a real application. And we have also, if you see, 3 potatoes there. And then in another image, we have only 1 or only 2 potatoes. We have a lot of, we have shadows. We have some partial, as in the watermelon, is a cut image, if you see. There are a lot of, how do you say?
Other questions? So let's thank the speaker again.